Bismillahirrahmanirrahim. Assalamu alaikum, student. If you are in first time in my channel, then please subscribe it and press the bell icon for the next videos. Thanks. Today my topic is gamma function. That what is gamma function? The first purpose of the gamma function is to handle the difficult integration. How to solve the difficult integration? So the representation of the gamma function is integral of 0 to infinity, integral from 0 to infinity x power n minus 1 e power minus x dx. It is the representation of gamma function. So just like in this example, gamma function, it is the integral from 0 to infinity x power n minus 1 e power minus x dx is equal to gamma of n. Just like in example, gamma of 5 is equal to 4 factorial. It is equal to 4 cross 3 cross 2 cross 1. So 6 gamma of 6 is equal to 5 factorial, 5 cross 4 cross 3 cross 2 cross 1. So gamma function is to handle the difficult integration. So the first purpose of the gamma function is to handle the difficult integration, and by solving or by substitution or by integration by parts, so we can handle the difficult integration. So at first example, I'll prove you that how the gamma of 6 is equal to pi per gamma of pi 4. 7 gamma of 7 is equal to 6 gamma of 6. So, and 6 gamma of 6 is equal to 6. So gamma of 6 is equal to pi factorial. So 7 gamma of 7 is equal to 6. So cross 5 cross 4 cross 3 cross 2 cross 1. So in first example, I'll prove that how gamma of n plus 1 is equal to n gamma of n. Just like gamma of 5 is equal to 4 gamma of 4. So in this example, I'll prove that gamma of n plus 1 is equal to gamma n of n gamma of n. So integral of 0 to infinity from the above integral of n, integral of 0 to infinity x power n minus 1 e power minus x dx is equal to gamma of n. So it is a 1 greater than n. It is n minus 1 and it is n minus 1 plus 1. So after I add to n minus 1 a plus 1, so it will give n. So the pictorial representation of this will be the x power n e power minus x dx. So by integration by parts, I'll solve this. So first function integral of second function minus whole integral of derivative of first function integral of second function dx. So first function integral of second function with an upper and lower limit, and the derivative of x power n is equal to nx n minus 1, and its integral is minus into e power minus x with integral from 0 to infinity dx. So if I substitute the upper and lower limit, then e power minus infinity e power negative infinity is equal to 0. So it will give 0 the upper limit, and the lower limit e power x is equal to 0. So 0 power n is 0. 0 multiply with anything, it is 0. So minus with this minus multiply with plus. So integral from 0 to infinity n will become out 0 to infinity x power n minus 1 e power minus x dx. So 0 minus 0, it is 0. So n integral of 0 to infinity x power n minus 1 e power minus x dx. So integral from 0 to infinity x power n minus 1 e power minus x dx it is equal to gamma of n. So it is equal to gamma of n plus 1. So gamma of n plus 1 give n gamma of n. So it is proved that gamma of n plus 1 is equal to n into gamma of n. Now the second example, that integral from 0 to 1 log of 1 over y whole power n minus 1 is equal to, this integral is with respect to y. So I'll make a suitable substitute in this integral. So log of 1 over y is equal to t, taking a natural, so by finishing this log, I'll take exponential. So 1 over y is equal to e power t and y is equal to e power minus t by taking its reciprocal. So differentiate this equation. So dy is equal to minus e power minus t dt. So put in equation a. So if I substitute here 0, so log 1 over 0, 1 over 0 is infinity, log infinity is infinity, so the lower limit is infinity, and log of 1 over 1 log of 1 is equal to 0, so the upper limit is 0. So infinity, integral from infinity to 0 log of 1 over y is equal to t power of n minus 1, and d of y is equal to minus e power minus t dt. This is the original integral. So I'll now integrate this, and by changing the upper and lower limit, there is a negative sign, so which is outer from the integral, which will be outer from the integral. So by changing the upper and lower limit, the minus will be cancelled out with this minus, it will be plus. So 0 to infinity t power n minus 1 e power minus t dt. So it is gamma representation, that in the place of x there is t, so it is equal to gamma of n by integral of 0 to infinity x power n minus 1 e power minus xo dxo. It is equal to gamma of n, and f is integral from 0 to infinity x power n minus 1 e power minus ax dx. It is equal to gamma of n divided by a power n. So just like in this example. Now what is the integral from 0 to infinity e power minus x square dx? So without using gamma function, you can't integrate this function because it is an error function. So we can't integrate this function with the help of substitution or with the help of integration by parts. With numerical integration you'll solve it, and with the help of gamma function I will solve it. So integral of 0 to infinity e power minus x square dx. So I have to first I will solve this with the help of gamma function. So let x square is equal to t, then dt is equal to 2xo dxo, dt by 2xo it is dxo, and from this x is equal to t under the root o. So dt divided by 2 into t under root, it is dxo. So put this in here in the original integral. So integral of 0 to infinity e power minus x square, e power minus x square is equal to t, so e power minus t, and dx is equal to dt divided by 2 into under root of t. So now it is a two-step integration. So 1 over 2 integral of 0 to infinity under root of 2. If I shift this to numerator, it will be negative 1 over 2 t power of minus 1 over 2 e power minus t dt. So it is now the in the form of the gamma function. So it is 1 over 2 and integral of 0 to infinity t power minus 1 over 2 e power minus t dt. It is equal to square root of pi. With the help of beta function I'll solve it in the next video. So integral from 0 to infinity t power minus 1 over 2 e power minus t dt, it is equal to pi under the root o. So integral from 0 to infinity e power minus negative x square dx, it is equal to pi under root divided by 2. Now the another example, integral of 0 to integral from 0 to infinity x under the root and e power negative of 3 square root of x dx. So I'll make a suitable substitution in the above integral. So let t is equal to 3 into square root of x. So by taking square on both sides, t square is equal to 9x. So by taking differential on it, 9 dx is equal to 2t dt. Now dx is equal to 2 by 9 t dt. So x under the root is equal to, from equation 1, x under the root is equal to t divided by 3. So this is the suitable substitution in this. So integral from 0 to infinity x under the root is equal to t divided by 3 and e power minus 3 into under root of x is equal to t, and dx is equal to 2 divided by 9 t dt. So by simplifying 2 by 9, integral of 0 to infinity 2 by 9 and multiply by 1 over 3, 2 by 9 0 to infinity, it is e power minus t dt, and t multiply with this t, it is t square. So 2 divided by 9 3 is 27, integral from 0 to infinity t square e power negative of t dt. So by simplifying it is a gamma function representation. So 2 by 27 it is equal to gamma of 3. So gamma of 3, 2 divided by 27, gamma of 3. Now the last example, integral from 0 to infinity x power n e power minus k square x square dx. So I'll solve it with the help of gamma function. So let t is equal to k square x square, then dt is equal to 2x k square dx. So dt divided by k square 2x is equal to dx, and x is equal to t, x is equal to dt divided by k square multiply by 2, and x is equal to, from this equation, from equation 1 t under root divided by k. So 1k cancel out with this k, then dt divided by k into 2 into t under root, it is dx. So substitute it in the original integral. So integral from 0 to infinity x power n e power minus k square x square minus k square x square is equal to t, and dx is equal to dt divided by 2k into square root of 2, and x is equal to what value of x? So x is equal to 2 into under root of t divided by k. So integral from 0 to infinity, so integral from 0 to infinity 2 into under root of 2 divided by 2 into under root of t divided by k whole power n. there is not 2 in this. X is only equal to t under root by k whole power n e power minus t dt divided by 2k square root of t. So it is equal to integral from 0 to infinity under root of t whole power n and k power n e power negative of t dt divided by 2k into root of t. So k into it is 2k and it is k power n, so it is equal to 2kn plus 1 integral of under root of n, and it is under t under the root and it is t under root n, so it is equal to t under the root power n minus 1 and integral of 0 to from 0 to infinity e power minus t dt. So it is the integrals. So integral from 0 to infinity, it is equal to t power of n minus 1 divided by 2 e power negative of t dt. So it is the representation of the gamma function 2kn plus 1. So it is equal to 1 over 2kn plus 1 gamma of n minus 1 by 2 plus 1. 1 over 2k plus 1 over 2k power n plus 1 gamma of n minus 1 by 2 plus 1.